All right, my last lecture on organic chemistry. So what makes organic chemistry really exciting are actually not alkane, alkene, and alkyne. They're okay, but what makes organic chemistry really exciting are functional groups, okay? So what are the functional groups? And I'm just going to get into it, and then instead of defining it, show you what they are. Basically, what functional groups are, they're groups that are attached to the carbon chain, okay? So for example, I have this carbon chain and I could have a functional group attached to it, okay? I'm going to say FG for functional group. So functional group are attached to the carbon chain and they make it organic chemistry a lot more exciting because they're more reactive and they have reactivity. So there are 10 functional groups we're going to go over. The first functional group we're going to go over are alcohol. Told you it's going to be exciting. Alcohol. Now, what is alcohol? Alcohol is when you have an OH attached to a carbon chain. So you have an OH attached to a carbon chain. Here's a couple examples. I can have an OH attached over here. I can have an OH attached to the end. Okay. Now, this one right here on the right-hand side, this is beer. When you're over 21 and you're drinking beer, I want you to think about this. You're going to say, I know this functional group. It has, and I know the structure. It has 2 carbon and it has an OH next to it. Hopefully you remember that. Now, so that's alcohol. The second functional group is thiol. Thiol is when you have SH attached to a carbon chain. So when you have SH attached to a carbon chain, okay? For example, you can have this. And SH doesn't really smell good. So garlic, onion, they usually have sulfur as part of their structure. So that's thiol. So alcohol and thiol, so far you know. Now, the next one is ether. Ether. Now, ether is when you have an oxygen sandwiched between 2 carbon. Okay? So when you have an oxygen sandwiched between 2 carbon. Here's an example. That's one ether. Here's another example of ether. Okay. Now, you probably have watched this in movies. Have you watched in movies that the bad guy has a cloth and it puts on someone's face and then they pass out? What is on that cloth? Sometimes chloroform, but sometimes it could be ether. So ether used to be used to knock people out. So usually on that cloth there's ether. You inhale ether and then you get knocked out. So that is ether. See, organic chemistry, exciting. So alcohol, thiol, ether. Again, ether is 2 alcohol sandwiched together. Now, before I go over the other functional group, I want to have a little side note. Okay? Carbon double bonded to oxygen. Carbon double bonded to oxygen. What that is called carbonyl group in organic chemistry. It's called a carbonyl group. And this is really matters in organic chemistry. So, carbonyl group, I have carbon double bonded to oxygen, right? Now, which one is more electronegative, carbon or oxygen? Hopefully you're yelling at me that is going to be oxygen. So oxygen is more electronegative, which means it's pulling the electrons toward itself, right? So it's more electronegative, is pulling the electrons this way. So because of that, I can say that the oxygen has a partial negative and the carbon has a partial positive because this is a polar bond and then oxygen is going to pull most of the electron this way. So what can you tell me about this carbon? This carbon over here is desperate for electron because the oxygen is getting the electron. This one doesn't have enough electron. Is desperate for electron, which in chemistry term it means is very reactive. Is desperate for electron, so it's very reactive, and it does a lot of cool chemistry. So I need you to remember that C double bond to oxygen is called carbonyl, and you're going to see that a lot in organic chemistry. So that was our side note. You're going to see this all the time in organic chemistry. Okay? All right, so again, remember this carbon is pretty reactive. Alright, because it's desperate, it doesn't have any electron. So alcohol, thiol, and ether. Now, the next one we're going to go over, number 4, is aldehyde. Aldehyde. Aldehyde is carbon double bonded to oxygen, and on one side, carbon is attached to the hydrogen, and on the other side is attached to the carbon chain. That is called an aldehyde. So, I'm going to draw some example. This is one example of aldehyde. In this case, both sides have hydrogen. As long as one side has a hydrogen, that's all matters. Let me draw another example of an aldehyde. This is another example. Okay, this is why this is so cool. You see this one over here? This is called formaldehyde. This is called formaldehyde. You've heard of that. Biologists, tell me, what is formaldehyde? It is used to preserve things, right? When we go to our biology lab and it smells really bad, it's usually the formaldehyde is used to preserve things. That's the structure of formaldehyde. It has aldehyde. Alright, this one over here. This is going to be a little bit interesting. When you go to the movies and you get popcorn and you put that butter on your popcorn, is it actually butter? Absolutely not, right? They're not going to use good butters at the movies. It's butter flavoring. And this guy over here, this is butter flavoring. So next time at the movies, when you're adding butter to your popcorn, think about it. It's like, oh, that's an aldehyde. This is butter flavoring. Still tastes really good. I still would go for it. But think about it. That's an aldehyde. You know that. See? Really cool. Now, number 5. So number 4 was aldehyde. Number 5, we're halfway there. Ketone. Ketone. Ketone is when you have carbon double bonded to oxygen again, and on both sides you have carbon atom. So aldehyde, at least one side has to be attached to hydrogen. Ketone, both sides are attached to carbon. So give you an example. Here is a ketone. Okay. Here is another ketone. Example of ketone in a compound. Now, this one over here on the left side, this is acetone. What's acetone? Nail polish. This is nail polish. Next time you use a nail polish, I want you to be thinking about that. You go, oh, acetone, I know what that is. That's a ketone. Carbon double bonded to oxygen and a carbon on each side. And now, what do they call it? Acetone. This is really cool. They call it acetone because acetone is a ketone. Yeah? Really cool. All right. So far, so good. Nice job. Okay. Let's go through next one. So the next one, number 6. Number 6, and my biologists should notice, is carboxylic acid. Carboxylic acid. Carboxylic acid. Now, carboxylic acid is, again, take a huge guess, C double bonded to oxygen. One side you have an OH, and the other side you are attached to the carbon chain. So one side you have to have OH. Aldehyde, one side has to be just hydrogen. Ketone, both sides have to be carbon. Carboxylic acid, one side has to be OH. Now, why do you care about carboxylic acid? Amino acids have carboxylic acid, right? So all the amino acids, they have carboxylic acid as part of the structure. So my biologists should know this really well. Also, let me give you a couple other examples of carboxylic acid. Again, organic chemistry, functional groups are so cool. This one right here on the left side, what is this? This is vinegar. This is acetic acid. This is vinegar. Vinegar is 5% acetic acid. So next time when you're putting vinegar on your salad dressing, what are you going to be thinking about? You're going to be thinking about, organic chemistry. This is a carboxylic acid. C double bonded to oxygen, and on one side is OH. Beautiful. Okay, next one. Next one is an ester. Ester is my favorite. Why is it my favorite? All the perfumes. They're made from ester. Or I shouldn't say all of it. Most of it. Esters, they smell really, really good. Now, what's an ester? Carbon double bonded to oxygen. On one side is attached to the carbon. On the other side is attached to an oxygen, but the oxygen is attached to a carbon. So carboxylic acid, it was an OH on one side, but ester is an O attached to a carbon. So again, every time you smell something that smells good, you're going to go, that's probably ester. Have you guys have Laffy Taffies? You probably have, right? So Laffy Taffies, there's like, what's the favorite flavor of Laffy Taffies? Banana, there's a strawberry, there's apple Laffy Taffies. Now, do they actually use fruit to make those? No, right? They just make it taste like banana or apple or strawberry. Now, here the structure of pear on the left side, and this is the structure of banana on the other side. Isn't that cool? This is what makes banana and banana. It's an ester functional group. This is a pear. So if they have a banana Laffy Taffy, probably they use this, they make this, and they add it to it, so it would smell and taste like banana. Now, this is why it's really, really cool. I want you to look at these two, pear and banana. Pear and banana, they smell differently. They taste differently, right? What's the difference between the two structure? Has an ester. This one has 2 extra carbon. That's it. Isn't that crazy? That 2 extra carbon, wow, it makes a huge difference. So for one more for fun, now that you know this about esters, this one right here is pineapple. This one right here is pineapple, right? Again, it's an ester, right? So if you have a pineapple candle, they probably synthesize something like this to make it smell like that, right? All right, so esters, they smell good. Every time you smell something good, you can go, that's probably an ester. C double bonded to oxygen, and then oxygen attached to a carbon on one side. So far, so good. Beautiful. All right, we're almost there. Number 8. There's 10 of them. 8 is amine. Now, amine, what it is nitrogen bonded to 1, 2, or 3 carbon atoms. That's an amine. Okay? Now, here's a little side note, okay? Here's a little side note for you, and I need you to remember that. Remember that nitrogen makes how many bonds? Nitrogen makes 3 bonds and usually has 1 lone pair. 3 bonds, 1 lone pair. Remember that as I'm doing this, okay? So, I can have a nitrogen attached to 1 carbon and 2 hydrogen and a lone pair. Or I can have a nitrogen attached to 2 carbon and 1 hydrogen. Or I can have a nitrogen that is attached to 3 carbon. So nitrogen makes 3 bonds. It could all be attached to carbon. It could be 2 attached to carbon. The other one would be nitrogen. Or it could be 1 attached to carbon. The other 2 hydrogen. So again, the point is nitrogen either has 3 bonds. At least one of them are going to be attached to a carbon to be amine. Now, here's what's really cool about this. Nitrogen in a ring. We talked about rings, right? We said that we have cycloalkanes and all that. Now, nitrogen in a ring, it tends to be addictive. Nitrogen in a ring. So when things have a structure that has nitrogen in a ring, they tend to be addictive. Caffeine, guess what? It has a nitrogen in a ring. Nicotine, guess what? Nitrogen in a ring. So anything you can think about, even Adderall, it has a nitrogen in a ring. Usually nitrogen in a ring tend to be addictive. This is a really cool little side note. that usually nitrogen in a ring seems to be addictive. Heroin, anything you can think of that is addictive, I can think of right now, there's usually nitrogen in a ring that makes it to be addictive. All right, so far so good. We are almost there. Next one, so we have amine. Next one are going to be amide. Next one is going to be amide. So, amide has, take a huge guess, carbon double bonded to oxygen. One side is attached to the carbon, the other one is attached to a nitrogen. And that nitrogen, again, could be attached to carbon or hydrogen. As long as you would have 3 bonds, you're good. Now, pay attention to this. That carbon double bonded to oxygen, and this carbon has to be directly attached to the nitrogen. So the nitrogen is directly attached to the carbonyl group. That's an amide. That's an amide. Okay. It could be NH2. Again, nitrogen needs to have 3 bonds. Here's another structure. So these are amide. These are amide. We're good? Okay. Let's review them before I give you my last one, which is my favorite one. I did say Ester was my favorite one. I can have 2 favorites. Alcohol, OH, SH, thiol, ether. You have an oxygen sandwich between carbon. Don't forget carbonyl, C double bond to oxygen. You see this all the time because this is so reactive. It makes organic chemistry exciting. Aldehyde, you have a carbonyl with a hydrogen. Ketone, carbonyl, 2 carbons on both sides. Carboxylic acid, carbonyl, but it has to have an OH that is directly attached to the carbonyl, right? It has to be directly attached. Directly attached. Okay. Now, Ester, carbonyl attached to the oxygen, but the oxygen doesn't have a hydrogen, like carboxylic acid. This was OH. This one, it has to be directly attached to another carbon. Amine, nitrogen bonded to 1, 2, or 3 carbon. Amide, carbonyl, and the nitrogen is directly attached to the carbonyl. Is directly attached to the carbonyl. So far, so good? Okay, beautiful. Now, last one. Good job for hanging in there. Last one is benzene ring. Last one is a benzene ring. Okay, what's a benzene ring? And this one, I think 80% of the drugs, I would say, probably have a benzene ring as part of the structure. Here's a benzene ring. Draw a cyclohexane for me and add double bond, double bond, double bond. They would have to alternate. Double bond, double bond, double bond. Okay? This is a benzene ring. Benzene ring is extremely stable. Most of the drugs, they have a benzene ring as part of the structure. A cyclohexane, and you have a double bond alternating double bond. Okay. Now, let me show you something really cool. This crazy structure you look at, it has 1, 2, 3, 4, 5 benzene rings together. So I said this is a benzene ring, is really, really stable. Okay? Most of the drugs have a benzene ring as part of them. Aspirin, Tylenol, Advil, they all have benzene as part of the structure. You know stuff now. Look at this structure, benzopyrene. It has 1, 2, 3, 4, 5 benzene rings attached together. 1995, this was discovered. What's the big deal? If you ever seen a commercial for cigarettes, for tobacco, at the end of the commercial, tobacco commercials, they always say, by the way, if you use our product, you might get cancer. Or if you buy tobacco, on the label it says, by the way, if you buy our product, you might get cancer. That's not a good advertising strategy, is it? Why would I say on my product, you're going to get cancer because people are not going to buy it? Why do they have to do that? They have to do it by law. They have to do it. But before 1995, they didn't. So it was speculated, suggested that, yeah, if you smoke and tobacco over time, it could cause cancer. But science always wins. Science wins. Remember that. So for scientists, They found the exact cause of it. This is in tobacco, this guy right here. When I look at this, I shiver. Because you know how we said one benzene ring is really, really stable? Check this out. 1, 2, 3, 4, 5. You have 5 benzene rings fused together. I look at this, I'm like, oh my God, what is this thing? I would never smoke. So you have 5 benzene rings fused together. This is when it goes and it binds to your DNA. It goes and it goes between your DNA. That's when you're going to get cancer. And it's irreversible. So this is what causes cancer when you smoke. And they found this. They found the structure. They went to court. All those big companies. But you can't argue with science, which is really cool thing about it. You can't argue with science. So, next time you see someone smoke, show them this. They say, you know what? Don't do it. This is what's happening in your body right now. All right, let's do a practice problem. Let's do a practice problem before I end this lecture. So, I'm going to put up a structure of aspirin for you. And it's really cool because next time you're taking aspirin, you're like, oh, I know what it looks like. And that is pretty cool. This is aspirin. Identify all the functional groups in aspirin. Now, to be even cooler, I'm going to also draw Tylenol. Look at you guys, all educated now. You know the structure of all these things. Hopefully this is going to motivate you to take more organic chemistry classes. This is Tylenol. So identify the functional group in these two. Pause me, do it. All right. Aspirin. What is this? Let me use a different. This is a benzene ring. I told you a lot of drugs have a benzene ring as part of the structure. Okay, what is this one right here? Carboxylic acid. So it's an acid. So that's why sometimes some people get an upset stomach because it's an acidic compound. What is this one over here? This one is an ester. You have carbon double bonded to oxygen. You have an oxygen that is directly attached to another carbon. So far, so good. Okay, let's come over here. What do you see? Oh, I see another benzene ring. It's pretty cool. What is this one right here? Alcohol. It has a different name. They also call it phenol because it's attached to a benzene ring, but you don't know that just yet. Alcohol, I'll accept. Okay, what else? What is this one? This is amide. It's not amine because NH is directly attached to the carboxylic acid. I'm going to go back over here. Remember what we talked about? This has to be directly attached. If the nitrogen is directly attached to the carbonyl, it ends up being amide. Attached is going to be amide. Okay. Again, you know these functional groups. These are the functional groups that make organic chemistry very, very exciting. All right. Nice job, class.